Hi folks, we're going to take a look at the solutions to the first quiz from Unit 6. So question 1 is a few factoring questions. Okay, and we'll try to remember the tricks we use for each of these factoring questions. So first of all, I just want to remind you to always look for a common factor. So here there's no common factor, and since there's no coefficient to x squared, this is just a matter of finding two numbers that multiply to positive 36 and add up to negative 13. Okay, so you just go through the different possibilities and you should come up with 9 and 4 as the ones that are going to work. Okay, so we have x, 9, x, and 4. And now we just have to get the correct sign. Since they have to add up to negative 13, it's going to be negative 4x minus 9x. Okay, let's take a look at B here. Now here we do see a common factor. So they both share a factor of x and they both share a factor of 8. Now another thing I'm going to do here is I would prefer having my leading term be positive. So instead of factoring out 8x, I'm going to factor out negative 8x. Okay, so let's see what we're left with here. So negative 32 divided by negative 8 is 4. Remove one of the x factors, I'm left with x squared. And then here we're just left with minus 1. Okay, however, I'm not done because I see that I've got a difference of squares here. This is a perfect square, 2x all squared, and of course, this can be seen as 1 squared. So I can keep going with my factoring. Okay, and the way I factor a difference of squares, it's the first term plus the second times the first term minus the second. Okay, let's move on to C here. So now I've got a trinomial, but the leading coefficient is not equal to 1, so I have to do a bit of work here. So the way I suggest you do these is by trial and error. Okay, so I'm going to do my algebra on the side. So we might decide here to start with, say, 1 and 6. Okay, so I take my two factors of 6, and I write them in the first column, and then I'll take factors of 10. So let's say I start with 2 and 5. Okay, now remember how this works. I'm just checking how the outsides and the inside terms add up. Okay, so I can either multiply 1 times 2 and 6 times 5, so 2 and 30, but that won't help me get to 7. I can also multiply 1 times 5, so 5 and 12. Okay, now 5 and 12 does help me get to negative 7. So I got lucky on the first shot. I found something that worked. Had I not done that, I would have had to try some other factors a second time. So here I'm going to have x and 6x. Okay, and here I need to multiply the x, the 1, by 5, so the 5 will go in that position. And then here I need to multiply the 6x by 2, so the 2 will go into that position. So I've got 5x and 12x. And so here I'm going to need, since it has to add up to negative 7, I'm going to have positive 5 and negative 12. Okay, so let's just do a quick check. 6x squared, 5x minus 12x is negative 7x, and negative 2 times 5 is negative 10. Okay, so let's move on to this one here. Now this is a trinomial, however, we don't have x squared as the leading term. However, I can rewrite this so that it does look more like a traditional trinomial as we have above. Okay, and what I can do is I can rewrite x to the 6th as something squared. In other words, x cubed squared. Okay, then minus 5 times x cubed. Okay, plus 4. Now, if you're comfortable working with the trinomial as is, you can do that. Otherwise, you can replace x cubed by an intermediary variable. So let's say I let z equal x cubed. So now I can rewrite this so it looks like a more traditional trinomial. So z squared minus 5z plus 4. And this now becomes something that's very easy to factor. So two numbers that multiply to 4 and add up to negative 5. That's just going to be z minus 4 and z minus 1. Okay, negative 1 minus 4 is negative 5. And now I'd like my final answer to be in terms of x. So I'll just replace my z's here by x cubed. Okay, so this will be x cubed minus 4 times x cubed minus 1. Okay, now let's take a look at this question here. Okay, and I see two terms with a subtraction in between. As soon as I see that, I should be thinking that this could be a difference of squares. And I look here and I see, well, this is a perfect square. Okay, this can be written as 5xy squared. And the second term is already written as a perfect square. Okay, so now I'm going to use same system as I did before. This is going to be equal to the first minus the second term and the first plus the second term. Okay, so this will be 5xy squared minus x minus y. Now notice here how I'm using brackets because I have to subtract the whole second term. Okay, and then multiplied by 5xy squared plus x minus y. And now here I can simplify a little bit because 5xy squared, this will become minus x and plus y. And then in the second one, it just remains 5x squared y, or sorry, 5xy squared plus x minus y. And that's as far as I can go. Okay, let's take a look at this last factoring question. And here, anytime you see four terms like this, you probably want to think of using grouping. Okay, now sometimes it's not going to be the first two and the last two, but I'd say that's what you should start by trying. So you group together the first two terms and the last two terms, and you factor each of these independently. So if I look at the first two terms, I see that there's a common factor of x in both and z in both. So common factor is xz, and here we're left with just x squared in the first term, and looks like that cancels out, so I'm just left with minus 1 in the second term. Okay. Now here, the idea is to recreate this expression when I factor the second pair. Okay. So I'm going to want that first term to be positive. So here, I'm not just going to factor out the common factor, I'm also going to factor out the negative. So it'll be negative. They each have a common factor of 2, and they also have a common factor of y. So I'm going to factor out 2y. And what we're left with here now is going to be positive x squared, and here 2y divided by negative 2y is just going to be minus 1. So I got exactly what I was hoping for, because now that they both possess x squared minus 1, I can factor that out. Okay, and here we're left with xz minus 2y. And here again, we notice x squared minus 1 is a difference of squares, so I can actually factor that a little more. Okay, and here we go, a set of pretty typical factoring questions. Okay, let's move on to number 2. So here, number 2, it asks us to determine the vertex for this function. Now we've got a couple of things we could do. We could try to factor it and then average the x-intercepts to find the x value of the vertex, and then use that to find the y value of the vertex. But since it's in standard form, I may as well complete the square. Okay, so let's recall how we complete the square. Any coefficient of x squared that's not equal to 1 must be factored out. So I need to start by factoring out this 4, and I'm only going to factor it out from the first two terms. So here I'm left with x squared plus 1. Sorry, x squared plus x. Okay, and then the minus 3 I'll worry about at the end. Okay, so now I'm going to complete the square on this term in the bracket. Okay, so the goal here is to create an expression that's going to give me my perfect square. And that expression is x squared plus, since I've got an addition there, 2 times what's going to become my h value. So in order to not change the expression, this coefficient of 1 now can be written as 2 times 0.5 or 2 times a half. Okay. x, and then in order to get my correct form, I'm going to have to add 0.5 squared, so that the first three terms factor to a perfect square. But since I've added something new into the expression, I'm also going to subtract it, okay, so that I don't actually change the value of the expression. Okay, so now here, the first three terms are what factor to the perfect square of x plus 0.5 squared. Okay, and then I'm left with negative 0.5 squared, so minus 0.25. Okay, so now I've managed to complete the square. To create my perfect square, I now just have to clean this up. So the first thing I'm going to do is I'm going to distribute the 4 to each term in this bracket. So 4 times my square, and then 4 times 0.25, so that's just going to be equal to 1. And finally, we have 4 times x plus 0.5 squared, and negative 1 minus 3 is negative 4. Okay, so now we've written this in vertex form, and we know that this is going to be my h value. So remember what vertex form looks like, ax minus h squared plus k. So in order for this to end up an addition, that means h has to be negative. Okay, so h, which is the x value of the vertex, will be negative 0.5, and the y value of my vertex is just given by that k value, so negative 4. Okay, so remember, when you're completing the square, always factor out any coefficient of x squared from the first two terms, complete the square within the brackets, and then make sure you clean everything up to have it in vertex form. Okay, so we're going to go to the last question on this quiz here, which is using the step pattern. Okay, so the step pattern really is useful when you have the a value and you have the vertex. So since this is already given in vertex form, I know that the a value is negative 2. That's going to allow me to determine my step pattern, and my vertex of 3, 8 gives me my starting point. Okay, so the idea with the step pattern is that starting from the vertex, y equals x squared grows in this fashion. So as I move up by 1, first the y values go up by 1, then they go up by 3, and then 5, and then 7, and so forth. Okay, so in this case here, in order to get the step pattern for my function, I just have to multiply the a value by each of these terms in the sequence. So the step pattern for this graph will be negative 2 times 1, so negative 2, negative 2 times 3, negative 6, negative 10, negative 14, and so on. Okay, you probably won't be using all these numbers. Okay, so now let's sketch this graph. Okay, so here we're starting at 3, 8. Now to give myself some room, I think what I'll do is on my y-axis, I'll go up by 2 units. Okay, so since this is going downwards, I'll try to put my vertex at the very top. So I'll make this 8. Okay, so 6, 4, 2. So that means I'll put my x-axis right here. Okay, and since I'm just going up by 1 every time for the x values, I'll actually use that as my scale, going up by 1. Okay, so the way this works is that we start at our vertex 3, 8. Okay, and now my pattern says that as I move up by 1 in the x direction, my y values are going to move down by 2. So from 8 to 6. Okay, now what I also use is the symmetry of the parabola to now draw a point on the other side. So I know I'll have another point there. So now from here, as x goes up by 1, y is now going to go down by 6. So 2, 4, 6. So there's another point, and again, there's going to be an alternate point on the other side of the parabola, and I think I got room for one more. As x goes up by 1, y is going to go down by 2, 4, 6, 8, 10. Okay, and again, there will be an associated point on the other side. Okay, and now that I have all these points, I can draw a fairly accurate parabola. Okay, try to fix that a little bit. Okay, and now we can draw the other side. Okay, and there we go. So we don't have to actually transform points. We don't have to make a big table of values, but this did rely on us knowing the vertex and the A value to determine the step pattern. Okay, that's it for this quiz.